It's great to see you all again. Welcome to semester 2 and Happy New Year. So this will be the first SPAAM seminar we'll have for this term. And our first speaker is wonderful Yueting. And you could see the topic board written over there. So the next voice you would hear and the next face you will see will be that of Yueting. Thank you very much.
Thank you. So first of all, thank you very much for inviting me here to give a talk. And I'm very honored to be the first speaker in this fresh new year in SPAAM seminar. And Happy New Year to everyone. I am Yueting Han, a PhD Year 1 student in Masters. So I'm here to give you a talk about a novel understanding of vaccination views competition on Facebook, interpreted by bow-tie structure of its online social networks. Some of you might be familiar with my talk since it's already my 4th time giving a talk on the same topic within a half a year. And it seems a bit crazy to me, but it's actually the first time for me to give a quite long version of it. So hopefully I will make good use of this time to tell you a better story compared with before. And meanwhile, this project is about to be finished, and I'm currently focusing on writing it as a paper. So I'm counting on you guys to give me some comments on the story that I am about to tell. Any suggestion would be much appreciated. And the last thing I want to mention before I give this talk is that as I am very keen on trying new tech, this slide is made through a very new platform called Gamma, which allows you to play with the slides and add comments on it if you want. There's a function like table of content on the left-hand side of it. So if you just put your mouse here and you can see things like that. So all those cards are actually foldable. So if you click things like that, so it's kind of interesting. So I have already shared the link to this slide in this team. So please feel free to play around with it as, yeah, it is interesting. So yeah. First of all, let me give you a brief introduction to this project. So this project is centered around the topic of online social media, which nowadays has become one of the main approaches for people to communicate with each other. Some popular platforms are like Facebook, Twitter, and Instagram. And vaccination view is one of the hottest topics on such online social media platforms. Although the relevant information is disseminated more rapidly than offline behavior, its little to no rules leave a large number of online users vulnerable to misinformation. So hopefully my research can help us understand how misinformation is circulated, and we can then seek relevant interventions based on this sense. And this project mainly started the vaccine views dynamics on Facebook, which appears to be a quite popular topic, especially after the COVID-19 pandemic. And 3 outstanding features of my research are highly cross-disciplinary, data-driven, and timely, which I believe you can feel when I walk you through my project. So just bear them in your mind for now. My research story begins with a Nature paper that tells us the pro-vaccine group is losing its battle on Facebook in providing less guidance to the neutral group than the anti-vaccine group. However, using the same data set, our project observes from an alternative perspective compared with the previous research that while the anti-group is estimated to have the largest number of followers for the next few decades, the pro later may exceed its number of followers in our projection. And we are able to provide some explanations for such kind of trend by studying the bow-tie structure of their online social networks. So to give you a better intuition for this project, let's check for the data set first. So the dataset that I can access from Jonathan Eighthouse Nature paper presents itself in a network structure. It describes the 2 snapshots of online competition between different vaccination views in February and October 2019. So for information, this is before the COVID-19 pandemic, and it involves nearly 100 million users on Facebook from across countries, continents, and languages. And figure A is a demonstration for the February snapshot. So each node is a public Facebook page that focuses on vaccination topics, Red, blue, and green colors represent pages with anti, pro, and neutral vaccine views respectively. Each node is also attributed with fan size, that is the number of members who subscribe to the Facebook page. Whereas its polarity remains the same for February and October snapshots, its fan size changes. And the directed edge from node A to B means A has ever recommended B to all its members at the page level. So we can more or less think of it as page A contains a hyperlink to page B. But in this sense, actually, the information flows from page B to page A. So it's kind of like opposite things. So as a pre-processing step, we define an edge weight to quantify the significance of each recommendation. So it is simply obtained by the product of both ends of fan size. So the detailed information about this dataset are listed here. So if you are interested, you can just check it further. So with this dataset, the first thing that pumped up of my mind to study is the fan size variation of each page, as this is a direct reflection for the opinion proliferation of each vaccine group. So for this, I actually did quite a lot of research on what factors will influence the fan size variation the most, including checking the in and out degree distribution in the network and epidemic simulation model for information spreading, and so on. But in the end, we found out that it's actually the initial fan size that correlates the most with the fan size variation. So let's see this section. And it happens to conform to a social phenomenon called snowball effect. So that is the number of followers in each page tends to either increasingly grow or decreasingly drop, as you can see in figure A. However, it is worth noticing that there are some nuances between anti, pro, and neutral group. So as to the anti group of red lines, its median size pages expanding the most. And by contrast, pro pages of blue lines generally drop the least across all interfan sites, and its increase is not restrained at the anti ones. So and it turned out that even if they appear to be minor differences in figure A, under like a simple agent-based modeling with data-driven assumption, while the anti-group is estimated to have the largest number of followers for the next few decades, the pro may later exceed its number of followers in our projection. Note that we are very aware of the situation that probably after 150 years, these pages will no longer exist, and such prediction makes no sense based on like this explanation. But we actually present this model not as a guarantee for the future outcome of vaccination views polarization, but as a reasonable projection based on our current ecology. So especially when we take a detailed look at the year from 2020 to 2045, we can see that compared with Jonathan et al.'s research on the like theoretical model prediction, the time point when the anti-group outnumbers pro-group is delayed for around 15 years. So this actually shows a sign of potential overstatement of anti-vaccine group strengths, and it raises our attention to investigate whether there are some plausible explanations for such kind of trend. So as usual, details are listed here. So like some kind of log-log polynomial regression things, and also a data-driven agent-based simulation. So in our research, we actually perform bow-tie structure analysis to explain this kind of things, and it actually have quite a good result, I will say. So next we move on to from the dataset part to like the methodology and the results part. So what exactly bow-tie structure is? It's actually a partition of nodes. So its initial form consists of three components: SCC in and out. SCC contains all the nodes that are strongly connected to each other, and in containing all the nodes with the directed path to a node in SCC and out containing all the nodes with the directed parts from SCC. And an example of bow-tie decomposition is illustrated in figure A. So this structure, as you can see, resembles a bow tie with its nodes at SCC and two vents as in and out, and that's why we call it bow tie structure. So as a reminder, in our context, each edge from node A to B means page A contains a hyperlink to page B. So in this sense, bow tie structure can provide useful intuition. Pages in SCC are usually active in both referring to other pages and being referred to, thus may be regarded as information propagators, whereas out pages are often cited by others but seldom mention other pages, behaving as information creators, and in pages generally acting in an opposite way, served as information listeners. Yeah. So the primitive bow tie structure was later refined by Yang in 2011 by extending the bow tie structure to include other components such as tubes, intangles, and outtangles, and others. And she also proved that any directed graph can be decomposed into bow tie structures. So there are also some research about the recursive bow tie structure. By considering bow tie structure of partition subgraphs. So its scheme is demonstrated in figure B. So following the research from Matei et al., we actually consider the subgraphs here to be discursive communities. That means groups of people who are thought to share some communicative purpose. So in our context, we interpret this communicative purpose in two ways. One is different vaccine groups, such as pro-vaccine and anti-vaccine, and the other one is detected communities. And for some of you who don't know what is community detection, it's actually a common network technique to find sets of nodes that are densely connected to each other, compared with other nodes in different sets. And there are a lot of choices of algorithm for its implementation. So here we apply a popular approach called InfoMap. Yeah. So let's check some experimental results based on this methodology. By applying bow tie structure on discursive communities interpreted by two ways in our dataset, we obtain the following experimental results. So for each diagram, the left-hand side represents the bow tie assignment in February, and the right-hand side represents 1 in October. And red, blue, and green represents anti, pro, and neutral vaccine groups as usual. So the first line, what we call within group, is like we study the bow tie structure of each vaccine group. And for the across group, it's like the bow tie structure of communities. So yeah. And we can observe like whatever this is within group or across group, we can always find like a large number of anti-pages are assigned out rows. So it is a sign of like a social phenomenon called infodemic effect. So that is overabundant information is produced inside the system so that the dissemination of such information is facilitated. So in fact, from the metadata study of Johnson et al., anti-pages are indeed good at offering potentially attractive narratives that blend topics such as safety concerns and conspiracy theories. And on the other hand, we can see that a large number of pro pages are assigned SEC rows. So it may confirm to another characteristic of social phenomenon called epistemic bubble effect. That is, a large number of people inside SCC tend to intensify their previous belief, and meanwhile being isolated from rebuttal. So in the research from Johnson et al., they indeed mentioned that pro-vaccine group has less interaction with neutral group compared with anti-pages. So it potentially suggests that pro-vaccine group may not be good at recruiting fans from neutral group, but maybe have like an advantage in consolidating their ideas for the bunch of people that has already believed in their ideas. Finally, the bow tie structure of neutral group seems less informative compared with the other two types, mainly because its temporal bow tie structure is much less stable compared with the anti and pro groups. And we consider this phenomenon to be understandable as neutral pages in some sense share less communicative purpose compared with pro and anti pages. And a final comment is that I have checked its statistical significance by using Newman's configuration models as random graphs. And most of the bow tie structures are indeed statistically significant. So some details are listed here. Okay, so now we have a quite significant discovery in different bow tie structures manifested by different groups, along with some potential insights of such bow tie structures, including epistemic bubble effect and infodynamics. So our last focus would be to build a simple bridge between the bow tie structure and fan size variation, and that's why we performed the following analysis. So instead of considering the regression for each vaccine group as before, we consider the regression for different bow tie rows in each group. So the results show that it's actually out in anti pages and SCC in pro pages who take the leading trend in fan size growth. It can be explained by our previous result that it's mainly these two parts that lead to the social phenomenon that we observe. And based on this sense, we can further extrapolate that their collective impact may be a driver for the estimated temporal domination of the anti-vaccine group in the online ecology as what we estimated before. Yeah, so basically, that's all about the experimental result part. So finally, for the summary section, there are some takeaway messages. So this project elaborates on the potential overstatement of anti-vaccination views proliferation in online vaccine views. And on the other hand, we also show that pro-vaccine group may have their own strengths. And meanwhile, this project also provides a refreshing picture of the infodynamics and echo chambers influence on the follower growth rate. And there's a final discussion part that you preparing some questions that you may want to ask. And some key question is because our data set is mainly focused on the period before the COVID-19 pandemic. Then you might want to ask, what about during COVID? So for that part, we actually have an updated data set with 2 snapshots during COVID, but it comes with 2 main drawbacks. One is that it's the nodes in this data set are slightly different from our original data set. And there's no way for us to find the node ID of each data set. And the other drawback is that the data set only contains constant fan size attribute. So this won't allow us to study the fan size variations across different time steps. So yeah, this is kind of the key things. But we did bow tie analysis on it anyway, since we are capable of doing so. As I mentioned before, bow tie decomposition can be applied to any directed graph. But the result turns out to be okay. So as you can see in this figure, the anti-group still holds a large number of still hold a large out group, and pro is SEC as usual. So this suggests that our observation before may still be valid during COVID. So yeah, that's basically all about my research. Thank you very much for your listening. Any question?